I planned on wrapping up most of the garden controller in this video, but we'll end up pushing the setup of the irrigation system and putting things in the garden into the next video. In this video, I will cover the Angular web application that is the user front end to the web services that are running on the microcontroller that's in the actual garden. I'll cover the main three sets of functionality. That's the overall garden view and tab, the history charting tab, and the settings tab. I'm not doing an in-depth Angular tutorial, so it mainly shows a demo of each function and how it's implemented, just high level in Angular. Also, the size of the garden UI web application has grown, so I'll wrap up by showing how I compress the files to better manage the space on a Raspberry Pi Pico. After these changes, I had plenty of room, so I could store almost a year's worth of log files. So just a reminder of the parts that make up the garden automation. So last video I was looking at the Garden Pico side of it. So this is the piece that sits in the garden, has a Raspberry Pi Pico, relays and things, and connects up to the irrigation system and decides when to water the garden and keeps an eye on it. It also hosts the Garden UI Angular application, and that's what this video is going to be about mainly. It's called Garden UI, and it talks over web services to the Garden Pico. Also, just a note that both these projects are in my GitHub repository, one under Garden UI and the other one under Garden Pico. And down in the description I've given the versions of these repositories as at the end of this video. Okay, now I have the web services mostly done down on the Raspberry Pi Pico. I can start calling them from my Angular application and get the interface working a bit better. So you see here I've set up a new service, just like the relay service in Angular. And at the moment I'm just calling the get sensors web service. So /sensors is the URL for that. And if you remember from the web services, it's basically calling, in my case, garden.home/sensors, and I get this JSON returned. Since the last video I added a couple more parameters coming back, the camera and the pump current status tells me whether they're on or off. So that's the service defined, and what that returns is an observable with that JSON in it. And so I set up a model. Normally I'd set up a separate model for each group of interfaces, but I think I'll just have one model file and put all my interfaces in here. So this is basically the JSON that's been returned, or the object being returned by the call to the sensors service. So that should look familiar from the what gets returned by the sensor service. I made all the properties optional at the moment, just so that initially it may not return anything. So this may be all blank, so it just allows me to initialize it properly, and then as they get populated, all these properties will be found. Now that's used over in my garden component, and we're looking at that in video number 2. So now I've extended that. So instead of calling the relay service, I'm calling the sensor service, and I'm setting this sensors, which we see defined here, which is using the sensors interface I just showed you. At the moment I'm setting it to basically blank, no properties in it initially, and then as it gets returned by this JSON call, it gets populated. The other thing I did here is I wanted some polling going on, so as things change on the in the garden, so battery levels may change, or the pumps may turn on and off, I want to keep checking this service, getting more information from the Pico about what the current status of things are. So I set up a polling using this RSJX interval operation, So this is saying every 15 seconds or 15,000 milliseconds. And normally interval is used to return a sequence of numbers. So I'm telling it to start with 0, but I'm not using the numbers. And the operation I'm telling it to perform is the get sensors we just saw over in the service. So I subscribe to that, and so every 15 seconds it's going to do a call out to the sensors web service, get the response, put it in the sensors, this sensors local storage. So whereas before it was initialized to blank, now it'll have all the JSON that gets returned in it, and they'll just go on continuously. I also extended this and added the camera toggle functionality as well, just like the pump toggle functionality. So let's try running that and see what happens. Okay, so we see the same interfaces before. I haven't updated my lousy picture here, but we'll do that as part of this working on the Angular application. I'm going to bring up the console so I can see what's happening. So I can see things like if I turn the water pump on, it's turning it on. We see the value changes. The other interesting thing is now if I go to history and go back to Garden, it's doing you can see it's doing a call out to sensors here and finding that the water pump's on, so it's giving me the values. The other things I filled in here were I've changed out on the Garden Pico, so now I'm only using 2 water sensors or humidity sensors for the garden, so just showing the 2 values there, and these are the values that's showing being returned from that sensors information, and you see it's getting updated every 15 seconds as well. So one other new field I'm showing here is amount of free space left, because again it's going to be tight for how much space I have available on the Raspberry Pi Pico file system for log files. So this will give me an idea. At the moment I've got 139 kilobytes free, which should be quite a bit for logs. I may need a little bit more than that. But I'm also thinking of compressing the Angular application, so that should save a lot of space on the file system. Last thing to have a look at here is in the actual HTML. So you see down here, this is where the new values are being shown. So things like temperature. So there's temperature here coming from the I2C sensor. It's using Angular expression to plug in the values that are being returned on sensors. So sensors humidity, sensors battery, sensors water level, also the soil moisture sensor readings here. One interesting thing here is to be able to deal with where these aren't filled in initially or aren't being returned. If there is, what this is saying is if there is a sensors SM1 property, so question mark is just in this case just checking that property exists, then it'll multiply the sensor value by 10. So remember, it gives you a value 1 to 10, so this is basically giving us a rough percentage value, otherwise just return 0. Same thing for sensor 2, and same thing up here for the sensor file free space. This is mainly because I wanted to divide by 1,000 to get kilobytes instead of just showing raw number of bytes. While I was working on Garden, I decided to update the picture in the background, so this is what it looks like now. So I basically took a picture of the garden, cleared out some areas for where the 2 soil moisture meters are going to get their readings. Again, the environment information in the center here. Showed a picture of my water pail where the pump's going to be located, so I can use that to host the toggle switch for the pump. Same for the camera. I've got a toggle switch under the camera for indicating that. So I think that looks a bit better. I'll probably
keep refining as I go along, but that looks a lot better than my previous image that I used on Garden. So I've also been working on the history tab or the history component. So what that does is much like when I was working on Solar UI, I can show history about, in this case, different parameters for what I'm logging in the garden. So this is an example of logging the environment details, so what's been coming off the I2C sensor, which is the temperature and the humidity. I can vary the number of days that I might want to look at those for. So this is now over 7 days. Now I've got about 14 days worth there, so varying the temperature and the humidity over 14 days. Now this is all happening in my office here, so I haven't got the box out in the garden yet, so they're really not telling me a whole lot because it's in an air-conditioned room. Other information available is irrigation information. So we look at the irrigation data collected over the last 14 days. Again, this has just been running in my room, so really seeing a lot of variabilities, but the red and the blue lines are showing the soil moisture meters, what they're reading, and really they've either not been plugged into the box or plugged in and just in the open air, so not really telling us a lot about the soil for this example, but that's what it'll look like. And I want to tie that in with the number of minutes that the pump runs, either each hour or each day, depending on what view I'm using. So I can sort of correlate when the pump runs for a certain amount of time during each day, how does it affect the moisture in the soil, and it'll help me change the timing on the pump to make sure the soil's wet but not too wet every day. And the final view I've got here is of the power usage. So again, not showing anything too interesting in the data because it's just sitting here in my office. Sometimes I had the battery plugged in, sometimes I didn't. But the series shown here is the number of volts that the battery's at. So that gives me an idea of what charge level the battery's at. And it'll be a lot more regular once I have the battery plugged in all the time. So it's going to be getting recharged with the solar system, but it's going to get drained by both the camera running and the pump running. So I can sort of see how long I can run these things over time as I watch this to see when do I start affecting the charge state of the battery, if I run the pump too much or if I run the camera too much. So those are the three views. So let's have a look at a quick look at the code, see how I put this together. Again, I won't go into the details. This is an Angular tutorial, but I'll just show you the main things I did to get it running. Okay, we saw in an earlier video how the actual Raspberry Pi Pico sitting out in the garden, when I make a request for history, it returns it in this sort of format. So it's basically JSON coming back with a log entry for the date range that I enter. So let's have a look first at the history service. So this is the one HTTP request which requests the history and returns it in that JSON format. For this I pass a start time, so whether I want 24 hours or say 14 days history, I just set the appropriate start time and it returns all the entries for that date range up to the current time. Then the actual tab component is this one here. I'm using the Angular Google Charts component here, and some material, a radio button. I actually had to use a select drop down to select the chart type that I wanted to show, whether it's environment information, irrigation information, or power usage information from what we just saw in the demo. The actual chart's picking it up from these fields or these properties in the code in the TypeScript component. So let's have a look at the TypeScript component now. Again, this is just going to be pretty fast. Look through how it's generally been built. So this is my TypeScript component. For the different chart views, I have different sets of chart options. So just chart options 1, 2, and 3 to cover the 3 sets of what series are shown and what prompts and things are shown on the chart. And depending on what chart is selected, I set the chart options to one of those 3 sets. So when it's first initialized, it does a do charting call, which is this one down here, and I'll do the charting based on, at the moment, what the default let's have a look here, what the default chart days is, which I've got set to 1 day, and chart selection is, which is the first option, environment. So by default, when it starts up, it'll go into do charting with those 2 options. So it works out when the start time is. If it's 1 day, then it knows to subtract 24 hours from that to get my start time. And then it sets some of the more of the chart options depending on what the chart selection is. So if it's environment, it sets the title, the chart options, and the chart columns names. For irrigation, it sets this set, and for power, it sets these set. Then it goes in, does a call to the get history service we just saw down here, and with the start time, gets the response from the subscription, converts the response into an object, and also changes the object into an array. It makes it easier to iterate through it into history by using this object.values. It changes the separate objects into array elements, which makes it easy to get through. I reinitialize the chart data. This is what's shown on the chart. Then for each element, so this is where we're iterating through the each element in that data. It selects the series that it wants to chart for that particular chart type. So again, for environment, it's basically getting the timestamp, the temperature, and the humidity. For irrigation, it's getting the 2 soil moisture meter values, converting it to a 100% range, and number of minutes that the pump's been on. And finally, for the power usage, it shows the battery level and what the number of minutes the camera and the pump has been on for. And then it just shows the chart once all that's been set up. So the last tab I had to fill in was the settings tab. I basically stole code from my Solar UI project as well. So this is what it looks like. Shows the settings when you go into the tab. You can make changes here. Let's drop that down to 2 seconds of pump time if I do an update. If it's the setting's not correct, it'll give me error messages, so let's take that up to 45 seconds. Same sort of thing you can do for webcam expiry. Must be greater than 5, so let's run it for 10 minutes by default. Also supports some pattern matching for this pump runtime, so this is meant to be a list of or commented limited list of 24-hour times for when the pump should turn on by itself. So let's put one more in there, press update, and go back to history, then have a look at settings again, and we see all the changes I put in there were accepted. The other thing I wanted to make sure of was I could use this on different devices, so let's do we'll bring up the debugger and look at it on different devices. So let's try the smallest device, try an iPhone SE. You can see the settings is responsive, so it changes into a vertical list when the page isn't wide enough to take it. I'd probably be using this sort of thing on an iPad mini, but I'm not using it on a full-blown PC. And you can see again that it's all responsive. We'll change sizes correctly and should work okay on an iPad mini. So let's have a look at the code. Okay, let's look at the code for the settings page. So first we set up a settings service. So this is what interfaces with the web services on the Raspberry Pi Pico. So the main service I'm using to get settings, which just returns all the current settings that are set. And then for each of the individual settings, I can do a get, in this example, pump on seconds, or set the pump on seconds by passing a value to it. Really, I'm not using the get functions here because I'm getting all the settings with that one there, so they're kind of redundant, but threw it in anyway. And then let's look at the actual code. So first let's look at the HTML. And for this I'm using reactive forms and the form component to help fill in a lot of the details automatically. It just it's a nice way of making forms where you don't have to get into quite so much detail. So in the code, again, I started off with a material card just to wrap the whole thing. Set up a form group. I'm calling it settings form, and inside that settings form I'm also setting a div with a class of grid wrapper, and this allows me to do the responsive design we just saw, where depending on the width of the page it either shows 2-column grid or a 1-column grid of controls. And then I have one of these mat form fields for each of the fields that I have in settings. So basically I think all of them are mat input fields. Placeholder, which is the name of the field, or the user readable name on the field, and then the actual form control name, and then conditions here on what to display if there's an error for any of the fields, depending on how I set up that field. And that's basically it for the whole page, and then just a update button at the end, which I press to tell the code to update the settings. Now let's have a look at the code. So like I said, I'm using form builder, form group, and validators from Angular Forms. That helps a lot with managing forms. Again, I won't get into the details of how all these things work, but I'll just show you the general flow through the program here. So I set up the form group. I'm calling it settings form. In the constructor, I'm getting the actual settings we saw before in the settings service. Get settings, gets all the settings, and then I patch those into the form. And because everything's got the same correct names, it patches in nicely. It fills in the form like we saw when we first went into the settings tab. And then we define the form group, the actual properties of each of the elements, and this is where the validators got set up. So this is where I was able to say, hey, for the pump on seconds it can be less than 30 seconds, couldn't be more than 500 seconds, where there's a pattern to match. About the only tricky one down here was for the pump times, where I have a list of 24-hour times on when the pump should come on automatically, and use the pattern to make sure that it just accepts a common delimited list of 3 or 4 digit numbers to represent the 24-hour time, and that's good enough pattern for me. I actually got that off ChatGPT. That's kind of nice for just doing things like give me a regex pattern for this sort of condition. So that handles displaying the form, doing the validation on the form, and then the last part is just the update of the form. So it goes in, see if any of the fields have been touched. You can see here control touch goes through each of the fields on the form, and depending on what the field name is, it does a call to the setting service and the set option for each of the fields if that field's been touched to update the field. And that seems to work. So the last change I wanted to make to the Angular program was to compress the files. So you see at the moment I've only got 127 kilobits free on the Raspberry Pi Pico. I really need 180K to have enough room for half a year's worth of log files. So I'm going to go through the process of compressing the Angular application and deploying that to the Garden Pico program. So first I installed gzipper. I've already installed that, so this probably won't do anything. So I just used the npm command to do that. Next I went through the normal build process. So this builds my Angular application and puts it into the dist Garden UI directory. So we see here we're at something like 600K of files, and there's also a little bit more because the new background image is about another 100K size. So I want to gzip everything that's in my dist Garden UI directory here. So I'm going to use this command. So using our gzipper utility that we just installed, I'm going to tell it to compress everything that's in the distribution directory and put it in distribution gzip. So it's told me 9 files have been compressed. And we can see the files that have been compressed here in the distribution gzip Garden UI directory. Just a note here, I don't need this assets directory, even though it created a gzip version of it. The only file I'm using is this JPEG file, which is the background image, so that's been gzipped and is in the top level directory now. So about the only other thing I need to do is remove the .gzip or gz extension on these. In the MicroDot web server, all the requests are going to be for the original names of these things, like the index.html. It doesn't know about the index.html gzip, especially in the actual runtime and main JavaScript here. So I'm just going to run through and do a rename to remove all these gzip extensions. This is kind of the long-winded way of doing it, but let's change into the Garden UI directory, this one here. And then I'm just going to do a rename from the command line. So you see now all the .gz extensions have been removed from these files. So the last thing I want to do is move all these files over to my Garden Pico application that runs on the Raspberry Pi Pico. So I think the best way to do that is just do a file copy. So I'm going to open up projects. There's my Garden UI, my distribution, my gzip one I just made, Garden UI. So I want to copy all these files. Then go to my projects. So my actual Raspberry Pi Pico program is here, and under Garden UI. So I'll get rid of the old files that were there and paste in the new versions. Now the final update that I needed is in the Garden Pico program in main, where it's serving up this content. And I've already made these changes here. So in the send file, I added compressed equals true. So this adds a gzip header to to the response coming back for requests for files. And the same thing down here for requests for the other files that make up the application. I added compressed equals true to the send file. So now if I force a reload of Garden Home, it's still working. We've got a lot more free space available, which is really plenty for at least 180 days of log files, so about 1K per day. And then if I look at some of the requests here, if we look at the headers, see in the response header it says content encoding as gzip because of that change we made in the main .py program.